This is NSAA 2021, Section 1, Question 48. So we're being asked to work out what are the possible oxidation states of the 4 sulfur atoms in the tetrathionate ion, which is given here as S4O6 2-. So a good place to start with this question is to try and draw the tetrathionate ion itself. So we know we've got 4 sulfurs and 6 oxygens and an overall charge of -2. How is the structure going to look? So how we work out the bonding is to look how many valence electrons they both have. And they both have 6 valence electrons. So using that information, see if you can draw an idea for a structure of this ion. So let's start with some sulfur first of all. It has 6 valence electrons, so it could make, say, 2 bonds if it bonded ionically. So we could have something like this, so each sulfur being linked to one another. So these are shared electrons and they're making bonds like that. And then we could add in our oxygens. So we know that these are missing 2 electrons to make an outer shell. So we could use some of these lone pairs here to make bonds with our oxygen. These now have a full outer shell. And we could do this with all of our lone pairs there. And we're left with 2 oxygens, which we can bond to the ends here. And we know that we need 2 negative charges. So if we don't make these double bond, we just make them single bond. There we go. We can have our extra charge there. So this is the structure of our ion. And now we can start assigning oxidation states. We know that the oxidation state of oxygen is usually -2. So we can write our -2's on there. Now they're going to be a bit different for our charged ones as they need to meet that charge, so it's only going to be -1 for both of these. And now we have our sulfurs. What are our sulfur oxidation states? Well, we can work them out using the equation, the number of valence electrons minus numbers in lone pairs minus those that are bonded. So for our 2 in the middle here, these are going to be exactly the same. We know that they have 6 valence electrons. There are 4 in lone pairs at the top and bottom there. And the number that are bonded is, well, we have 2 electrons here, but because they're shared between the same atom, we have to half it. So we're going to be 6 minus 4 minus a half of 4, as these are both are bonded ones. So that's 6 minus 4 minus 2. That gives us 0. So these are going to have an oxidation state of 0. If we do the same for our ones bonded to the oxygens here, we know that the number of valence electrons again is still 6. There are none in lone pairs now this time, all the electrons are bonded. And the number of bonded electrons this time, we don't include the ones that are bonded to the oxygens, as the oxygens are more electronegative and so pull their electrons closer to them, and they're not counted in the sulfur. So this time we only have 2 electrons that are bonded, and again we need to half it because it's shared between 2 of the same atom. So we're going to have 6 minus 0 minus a half of 2. So that's 6 minus 1, or 5. So these are both going to have +5 oxidation states. So overall, our answer is +5 +5 0 0 for our oxidation states of sulfur, and our final answer is D.